Okay, so my name is Tuomo Hiippala. I'm an assistant professor of English language and digital humanities at the Department of Languages at the University of Helsinki. And what I thought about talking about today is my field of research, which is probably unknown to many here in this room and generally not well known because it's fairly new. So the field called multimodality research, and what is meant by multimodality is basically the idea that human communication relies typically on combinations of different modes of expression. And you can think about, for example, face-to-face interaction. You combine spoken language with gestures, gaze, posture, and then those kind of different modes of expressions are coordinated when people communicate. And in other situations, let's say you think about a broadsheet newspaper, for example, combines written language with images, diagrams, photographs, and which are all organized into layouts. And then in some different communicative situations, you might have combinations of both, like this kind of audiovisual presentation. I'm coordinating my speech with this kind of additional visual support that I have here in my presentation. And this is obviously something which might be of interest, to many fields of study, let's say communication and media studies, linguistics, and many more. And indeed, the idea or the phenomenon of multimodality has been acknowledged in several fields, but the concept how multimodality is understood is very different and depends on the field in question. So if you think about something like human-computer interaction, where multimodality is a big issue, they typically think of multimodality in terms of modalities, like let's say you have a video, so you might have like an image signal that needs to be processed and decomposed in some way, and the same for audio signal, or then you might have some kind of tactile signal as well. So they pretty much in human-computer interaction and signal processing, the idea of a modality or a mode of communication is pretty much aligned with the sensory modalities that we have. But in linguistics, for example, the definitions are much more fine-grained in the sense that they cut across these kind of sensory modalities. So if you think about something like spoken face-to-face interaction, you have some visual cues like gestures and posture and gaze, and then some auditory resources like the spoken language and its characteristics, let's say intonation and all the other features that come with it. So those kind of cut across the visual and auditory modes. Now, the thing is, for a long time, all of these different kind of multimodal phenomena have been studied in different fields just because of the tradition that how these kind of different disciplines have developed. So linguistics, or let's say linguists typically for a long time just studied language, and let's say art historians might be looking at static images, and what else could be an example? Film and television studies would look at audiovisual media and so on and so forth. But now there is this kind of increasing interest in actually theorizing this phenomenon of multimodality, and a lot of that work is being done within, let's say, communities originating within the field of linguistics. And one reason might be that linguistics, for example, has described a very complex mode of expression, that is all sorts of different natural languages on different levels of detail for a long time. So we have models from, let's say, the smallest meaningful parts of words, so morphemes, to entire texts and beyond. And at the moment now, the field is very much kind of like open field, and of course there's a lot of research being done in different areas, but slowly like these kind of common theories about multimodality are coming together, and some key questions at the moment is like, how do you actually define a mode of expression? So what are the prerequisites for a mode to emerge? Of course, for that part we know mostly about natural language. And then also, what is the role of, let's say, the medium of expression for multimodality? So if you have something like embodied communication, so face-to-face interaction, or something that relies on the human body, or let's say some kind of two-dimensional space for presentation like this screen or a sheet of paper. So how do these kind of the underlying properties of the materiality affect the expressive resources that are available to you? And of course, how to analyze these. Language is actually fairly easy in this case, because you can define some units of analysis. Then when you're faced with multimodal communication, defining the actual units of analysis becomes much more difficult. Like, for example, how do you decompose a photograph into some set of objects or entities? Now, this has been all very theoretical, so I'm just going to jump into an example case, and then I'll talk a bit about my current project. But let's say, I think we actually had quite nice examples in the previous presentation, where you had something, you had the image of the peat bog, and then that was a photograph, and then superimposed on that you had a diagram. And diagrams are particularly interesting to me because it's the kind of mode of expression which combines natural language, then various kind of graphics, meaning photographs and illustrations and whatnot, and then diagrammatic elements such as lines and arrows, which you had there in the diagram as well. And that's one of the funny features of diagrams is that they contribute the kind of individual elements in the forms of graphs and charts and all sorts of different kinds of which could be understood as proper diagrams. But then again, diagrams or diagrammatic elements very easily attach them to other modes of expression, like in your case, and in this case of this aerial photo. These kind of labels and lines are not inherent to the photograph. They've been added later, and this is one of the kind of things that the diagrammatic mode tends to do. So when you need to pick something out of some other mode of expression, then diagrammatic mode is what you need for that purpose. And the funny thing is that we don't actually know too much about these mechanisms. So how do diagrams actually work from the perspective of multimodality? So how do they combine different modes of expression? So my current project focuses on the multimodality of diagrams in elementary school science textbooks from the United States. And this choice was motivated by the fact that there is an existing dataset for this purpose. So something called the Allen Institute for Artificial Intelligence Diagrams dataset, which contains about 5,000 diagrams scraped from the web. They've been collected using school textbook or science textbook chapter headings as seed terms, searching the web and then scraping the diagrams. And then they've been crowdsourced or annotated on a crowdsourcing platform. So essentially on Amazon Mechanical Turk, I don't know how many of you are familiar with these kind of services. So basically they are platforms online where people do micro tasks, like let's say draw a bounding box around every text block in this diagram, and they get paid for that. So in the dataset you have about 150,000 diagram elements altogether, and also the annotators have been asked to describe the semantic relations between the diagram elements. So it's quite a big dataset in terms of its size. And it's something that's not really available. These kind of resources required to create these kind of datasets are not really available in my research community, so it's useful to get something from the outside, and obviously artificial intelligence is one of those topics that gets a lot of resources and funding at the moment. Now, from my perspective, because the annotation schema used to describe these diagrams in the original dataset was developed by computer scientists, the description is a bit vague, but I won't go into the problems too much. But generally, when describing multimodal phenomena, the typical approach is to take this kind of standoff approach to description. So you describe different aspects of, let's say, whatever you're studying, and keep those descriptions separate, but then later join them somehow, typically using like unique identifiers across elements. And I'm going to show to you in a moment what I mean. But what we're basically doing is we're developing this kind of multi-layered annotation framework for describing these diagrams in a consistent manner, and then providing a resource for empirical research on looking at the structure of these diagrams. And basically, what we're doing is we're building on top of the crowdsourced annotation for the layout segmentation. Layout segmentation meaning these kind of different elements that the crowdsourced annotators have picked out. So text blocks, diagrammatic elements like lines and arrows, and then these kind of polygon shaped blobs, typically images, many sorts of different kinds of images. And then we use that as the basis, and then I have 5 trained research assistants doing the annotation on the basis of this kind of crowdsourced non-expert annotation. So what they're basically doing is creating 3 separate representations of the diagram structure, which are represented using graphs. And the first one, unfortunately, this is a bit small. I wonder if I could zoom in a bit, but I'll just maybe try to point it out here. So we have basically 3 layers of description. One of them corresponds roughly to the kind of visual groups that are presented to the viewer. So things that generally seem to belong together, mostly based on Gestalt principles of visual perception. So let's say, for example, the labels and lines, and that's represented here in this diagram, graph. And then we have another graph for describing connectivity, because diagrammatic elements do a lot of communicated work in diagrams, obviously. So here we have the blob in the middle, and then all the connections from these labels represented using this graph. And then finally, we have a representation of the so-called discourse structure. So what kinds of semantic relations hold between the different diagram elements. And for that purpose, we use theory originating from linguistics called rhetorical structure theory, which is a theory how these kind of bigger pieces of discourse are organized. And for example, in this case, these labels are picking out parts of the object, so that would be described using this relation called elaboration, which adds information to something. But the thing is, looking at this kind of, how would I say, visual data also requires developing new methods for analysis. So in linguistics, traditionally, this kind of like large volumes of data, you look for a certain pattern, and then you get lines as response, like collocations, so the context in which word appears, for example. That's much more difficult to do with this kind of data, so we're looking at using graph neural networks for representing or learning about the structure of these diagrams on the basis of the graph-based representations, and then clustering them to maybe find some kind of prototypical patterns in the diagram structure which are not dependent on what the diagram looks like. And I'm just going to show you a couple of examples because I still have a few minutes. So these kind of graphs actually, and the annotation schema that we've developed, can bring out structural differences in different diagram types. So let's say here you have a typical example of a life cycle that especially you can see that in the connectivity graph that you have this kind of directed graph between nodes. And then when you have a different type of graph like this, which picks out a part of the flower, and then you have this kind of call-out structure showing the part in detail, then you have this kind of, again in the connectivity, if we focus on that for the time being, you see that there's this kind of like, how would I say, not this kind of connected graph, but more like random connections between the parts that are picked out. And then of course maybe the clearest example would be the final one where, sorry about the, you can probably see here is a food network, another very typical diagram type in the dataset. So here again you can see that you actually have a network here, and obviously there are several differences in the discourse structure as well, but I won't go into that detail too much. But the basic thing is that we can see structural differences in different diagram types using this annotation schema. And what is particularly interesting for me, and what I'd like to look at now in the next year or so, is that because these graph-based representations of the diagram structure seem to be able to capture these kind of differences between diagram types, so how much of this information, or how beneficial it would be for training algorithms that for automatic diagram understanding, because the state of the art using the original diagram dataset now builds only on structural information. So basically the graphs that are used to represent the multimodal structure of the diagrams, and not the kind of visual appearance. And if you've been following, let's say, developments in computer vision and so on, those advances are mainly limited to photographic images, which are kind of easy in the sense that photographs tend to look alike, but then again, when you go into the domain of, let's say, all forms of other graphical expression like diagrams or illustrations, there's a lot of visual variation that the algorithms cannot handle. So my question is that could we somehow, coming from the humanities side, help, let's say, describe or develop annotation schema for informing the research on artificial intelligence? And then on the other hand, I mean, linguistics, for example, was, well, underwent quite a big revolution with when optical character recognition became available, so text could be scanned automatically, and the corpora, the size of like datasets really blew up. And obviously now you can you have big web-based corpora, but in my field the data tends to be very small. So my question is also that could artificial intelligence do part of this annotation and data description, and thus support empirical research? But yeah, that's pretty much all I have to say about this topic. So thank you.